What's up, everybody? How's it going? Today, I am joined for the second time by the one and only Ben Awad. We are doing a second mock Google coding interview. If you remember, a few months ago, we did an easy Google coding interview where I had Ben reverse a linked list and invert a binary tree. Today, we are doing a medium difficulty coding interview because that was a pretty easy one. And Ben, are you feeling good?
I'm feeling a little bit nervous. I haven't seriously thought about algorithms or linked lists in a couple months. So I don't know what to expect.
Well, listen, I think this one is going to be fun. Either way, whether you struggle or not, it's going to be a good learning experience for you and the viewers. So let's jump into it. We're going to have roughly 45 minutes on the clock. We're going to be using the AlgoExpert mock interview shared workspace user interface for this interview. By the way, if you're preparing for your coding interviews or systems design interviews or machine learning interviews, then check out my company, AlgoExpert. Go to algoexpert.io and use the promo code CLEM, C-L-E-M, for a discount on the platform. Then, in a real Google coding interview, the interviewer wouldn't be shilling their product in front of you. So
I'd be on Google Docs right now. Yeah.
We'll probably move to Google Docs for the hard Google coding interview that we do in the future. But okay, ready?
I am ready and willing.
All right, the clock starts now at roughly 56 minutes. I see on the stopwatch, so we'll go roughly until about 10 minutes. So Ben, I want you to imagine that you have a black and white image. So the black and white image consists of pixels, or rather it's represented by pixels, and these pixels are either black or white. Now the representation of this image is going to be in the form of a matrix, which is a two-dimensional array, and that two-dimensional array only has the numbers 0 and 1. 1 represents black, a black pixel, and 0 represents a white pixel. So for example, if you look on your scratch pad here, do you see this two-dimensional array that I pasted?
Yep.
So that might be a sample input that represents the black and white image. Now you are going to be tasked with removing all of the black pixels that are not connected to the border of the image. So when I say connected, I mean two pixels that are, or two or more pixels that are either horizontally or vertically adjacent. And if they are not connected to the border, then you have to remove them. And the reason that the function that we have here is called remove islands is because we're going to call these blocks of black pixels that are not connected to the border, we're going to call them islands. And so you want to remove them. So I'll give you the sample output for the input that I gave you here. This would be the sample output here. And it might not look like much here, but I'll show you another thing. This array that I'm about to paste here, this shows all of the islands that we removed. So you can see that between the sample input and the sample output, we removed this island here that had 1, 1. We removed this one that had another single 1. And then we removed this one that had 2 connected ones. And none of these 4 islands here, or sorry, 3 islands rather, there are 3. None of them were connected to the border.
Yep. So it's not diagonal too. It's just left, right, up, down.
Exactly. So you might notice that in the sample input, if you scroll back up, there's a 1 in the top left corner. The 1 here in the second row, second column, we removed it, even though it was diagonally connected to the top left corner, because diagonally just doesn't matter.
Right. Okay. I think I get it now. And I know how you're supposed to solve this. I'm supposed to create a graph of all the ones, and then I can see which one is not connected by doing, I guess I could do a depth first search, but I kind of that feels too algorithm heavy. I kind of want to just do a for loop and see if I can do it without creating a graph. / I forgot how to do graphs too. So my initial thing is I want a for loop here. And I think, so the first thing I thought of was all right, I could do one pass to identify all the ones on the edge. I assume the matrix is going to get really, really big, right? That's the idea. And so I can't
yeah.
So this,
ideally
I'm guessing this would be too slow to so this was my first thing. This is the slow version, right? So I take the outer ring and I do the inner ring and then the innermost ring. You know what I mean? So I would do like, so this one has 3 levels. The outermost level and then 2. But that's going to be too slow. Actually, what would that be? Okay, look,
I would say
can I do
maybe
it?
to start, don't worry
Start
about
slow?
don't worry about optimizing the solution.
All right. I'm going to go really slow then. All right, so this is going to be, so I need to store the ones that are on the edge. So I'm going to call this edges. And I'm trying to decide if I want to make this a dictionary. I think I do. And I think the dictionary, how this is going to work is I'm going to store like 0, 0, true, 0, 1, false. Actually, I'm trying to decide. Yep. So how this is working is this is going to be the rows. This one's going to be the columns.
Okay.
And
what does true and false represent?
True means it's an edge. False means it's not an edge. So then we're going to for loop. And actually, I could probably do this. Oh, I can actually do this very fast too.
Just, Ben, when you say not an edge, you mean not on the border, or you mean...
Okay, yeah, I see what you're saying. So yes, it's not on the border and it's not connected. So what I'm starting at the very, so like the very left side, the very right side, the very top, the very bottom. That's what my first loop is going to touch.
Okay.
And I'm going to say whether it's a 1. Okay, so true means it's a 1 and it's an edge. And
Okay.
then I'm gonna do that again on the second ring, and I'm gonna do it again on the inner ring. Okay, this sounds really jank, but this may be really jank. So we're gonna start here though, because I actually don't know why I'm starting here, but we're gonna start here. All right, so for I in matrix, this should be for row. And do I want to enumerate? Let's enumerate. Enumerate. So enumerate should give me the index and then the value. Ooh, now the real question is, does enumerate? I think the first one is the index. Let's do a little test.
Okay.
Run code. Yeah, it failed. Does it give me output though?
If you click the raw output, you should see it.
Okay, perfect. I did it right. Yeah, so I just want to make sure this was literally the index and this is literally the row. And it did look right.
And just, Ben, I don't mean to interrupt you in the middle of your thought process, but when you say you're going to be going through these inner rings, I understand that, but walk me through how, like, what do you do when you're at ring number 2, like the second inner ring? Like, what information from the first ring is going to suddenly be relevant to you?
Well, I know based on the outside ring which ones they're touching.
Okay.
And so I'm going to use the computed edges. This is actually going to be recursive. I actually don't need a for loop here. Because okay, this is really hard to say in words what I'm doing. Can you see my cursor in the scratch pad?
Yep, I do.
So like I'm literally going to touch this row.
Yep.
Then I'm going to touch this diagonal column. Then I'm going to touch this diagonal column. Then I'm going to touch this. So that's what my first pass is. And then my second pass is going to be this.
Yep.
This. This. And then this.
Yeah, so the sort of like perimeters of the
this.
squares.
Yeah, there we go. I got it. That's my jank algo.
But again, it's like, let's say you are at, I don't know, this one. You see this one here,
right,
in the second row. What do you do from here? Because you see that it's a 1. How does this sort of like help you get to the outcome you want?
I have everything stored in edges, right?
Yep.
So I'm going to look at my edges map and I'm going to say, is this an edge? Is this an edge? Is this an edge? Well, actually, it doesn't help me downwards. Wait, is this actual trash then? Oh, I'm going to have to do this backwards. Oh, this is disgusting. Actually, this doesn't work at all. You're right. Good thing you're stopping me now. I was going to go down a really bad path.
Well, it's not necessarily bad, but like there might be some, quirks about it that make it, not really lead you to the outcome you want.
All right, am I literally just going to compute a graph? All right, screw it. We're going to compute a graph. This is just a graph problem. Why am I using
Yeah. So walk me through what you meant by a graph, because you made it sound like
Right.
like a graph was super complicated, but walk me through it.
All right, so this is what I'm thinking graph-wise is I'm just going to basically I want to see which like the ones that are touching each other. And
Yeah.
I don't care about zeros here. All like my first thing to compute the graph is just going to be the edges are ones that are adjacent, basically.
Yeah.
And that's how I'm going to compute my graph. And then after I compute my graph, I mean, that's not too bad, I suppose. All right, let's start there. This is the right approach, I'm pretty sure. So we'll just do a graph. I didn't want to touch graphs because graphs are a little gross. / I like forgot. We're gonna like do graphs on the spot here.
Okay.
So do I want an adjacency list? I think I do. Oh, you know what? This is a matrix. I bet I'm supposed to use the graph representation of a matrix, but I totally forgot how that works. So we're gonna do an adjacency list. So that's gonna be a little jank. All right, so we're gonna loop. I still care about this for j call. Actually, this is just gonna be a value.
And sorry, Ben, I again don't mean to interrupt you because I know
Yeah.
you're in your thought process, but the graph, what are you gonna use the graph for? So like let's say you have a graph that maps like one to its connected ones or something. How does that help you?
Basically, I'm going to do a depth first search of every graph. And then, so like that's the other thing, right? These are all disconnected graphs. So there's going to be an array of graphs, I guess, now that I think about it. So for each graph, I know if it has like a one that's on the edge. And then I know that entire graph is connected.
So each graph represents effectively one cluster of ones.
Yes.
Or one island. I see.
So like this, let's go up to the top. So like this would be an island.
Or would be a part of the graph.
Yes. So that this entire block thingy here would be an island. This would be an island minus the zeros. And then for each island, I guess you're right. Why I don't even technically have to do depth first search. I just know that the entire island is good. Maybe this problem's actually easier than I thought because it's actually okay. I think I know what I'm doing closer now. Because I know if at least one like item in the graph is an edge, then the entire thing is good. / you
don't want to remove it. Yeah.
Right. So all I'm looking for is a graph where none of the ones are edges, and then I remove it. That's all I'm doing. Okay.
I see. And so just to re-clarify, when you're saying the word graph, you're effectively saying like a cluster of connected ones or a group of connected ones.
Right. So yeah, my graph is connected ones.
Okay. And how are you representing them? Like here you have an object. Like what are you storing or a dictionary in Python? What are you storing in that?
So adjacency lists, I remember there's something like this. They have some key and then they have the list of edges. That's all I remember. So I think what that means in this case is this is going to be an index. So like 0, for example, because that's going to be like where one of the ones is.
Yeah.
And then it's going to have a list of all the edges. Oh, you know what? I guess so I was thinking of directed graphs, where it's like one edge points to another. I guess in this case, they're connected both ways. So I have to actually set it up both ways. We'll set it up like that. But anyway, so like, actually, let's take this one down here since 0, isn't connected to anything. So in this particular case, what I'm thinking of representing this as is we have 0, 1, 2, 3. So that's going to be 3, 0, points to 3, 1. and it also points to 4, 0.
Okay.
So that's what I was planning on representing it at my adjacency.
So I have two questions for you here.
Okay.
One, do you think that you need to create this adjacency list, or do you not already have a graph within this matrix just by nature of having like a two-dimensional array?
You're 100% right that I probably don't have to make an adjacency list, specifically because you're asking me. I know I definitely don't need to make an adjacency list.
Fair enough. That was perhaps a bit of an obvious question, but I suppose like what you wrote here, right? 3 0
Yeah.
pointing to 3 1 and 4 0. You have that already, right?
This is a graph. You gave me a graph. I just have to remember how to use a matrix graph.
Well, how when you are at this one, the 3 0, sorry, I haven't highlighted it. This one,
Right.
3 0, you can access 3 1 and 4 0 directly, right?
Right. I mean, okay, we could technically do like a little depth first search at every. Okay, why don't we do that? Okay, that's kind of spicy. Okay, so like every time I hit a 1 that's on the edge, I depth first search it.
That might be a little bit. But that might be all you need. Exactly. That might be all you need, right?
Yeah. Okay, let's start there then.
And to be clear, it's not that you don't need a graph. It's that you have.
I already have a graph. Yep. Okay, good. You're right. Thank you for reminding me how to use matrix graphs. I don't remember them at all. Okay, so yeah. So I'm going to literally depth first search every time I hit a 1 is my plan. All right, so sorry, I'm going to go back. I literally had the enumeration already set up. I don't know why I did. Do I care about enumerate anymore? I think I still do. All right, if value is equal to 1. Oh, sorry, I've been in Elixir land. They put do at the end. Okay.
Yeah, I was like, is this some new Python?
No. I caught myself. Okay. So we got value is a 1. This is where I'm going to depth first search. And so now what I need to think about is I already know whether it's an edge here. Really what I care about is seeing all. I don't care that this is a 1 actually. I care about if it's a 1 and it's an edge. Then I want to do my depth first search. So actually that's what I want to do.
And again, to use the terminology, because edge is like terminology in graphs. Also,
Right.
When you say edge, you mean border here.
Yes. Okay. Border is what I'll use instead. Okay. So yeah, if I find a border 1, that's when I start depth first searching. And we'll call this border islands.
Okay.
That's probably a better name. All right. So now I need to detect if it's a border, and I know if it's a border if I is equal to 0, or if I is equal to the length. So actually, let's create a new function up here. Def is border.
Beautiful.
Crap, I'm gonna put do's everywhere. All right, we'll do pass. And the only thing that defines whether it's a border or not is the 2 indexes, I and j. So that's what we're passing in. So is border I, j. All right, so if I is 0 or I is equal, actually we need to know the length of the row. So row length, call length.
Okay.
And it's going to be row length. So what I was trying to decide there for a millisecond was whether this was 0 based and I should -1 here, but we're going to -1 when we pass it in, I think.
Okay, sure.
And we're going to return false. And obviously we do the same thing with call, which is j. So if j is equal to 0 or j is equal to call length. By the way, are these always square matrices?
No, they can be rectangular, but they can't be weird shapes.
Okay.
So
Okay.
it's correct to have 2 different row and call lengths.
Yep. Okay. All right. So this is going to be the length of row, and this is going to be the length of Oh, you know what? I'm being a pleb, I think. So this is, so we're iterating through that. That's going to be a row. Okay, so it's going to just be matrix length. Now, I actually think I'm supposed to inverse these.
Yeah.
This is, yeah, I need to decide whether I am switching these two or if I'm keeping them the same.
Yeah, this isn't the most interesting part of the code. So yeah, like here, yes, len
I'm
of row should
switching
be
matrix, yeah.
len of matrix, and here I do believe you have off by 1 errors since you did your.
Oh,
thing
I'm going to
up
minus
here.
1, yeah.
Okay, yeah, yep.
So if that's the case, I actually think that's fine now. So now I know this is a border island, so I can stick this in here if I want to. I don't remember how to use F strings. Actually, I think I do. Can I just do it like this? Some Python people are gonna laugh at me.
To be honest, I have no idea. I would personally just do like I dot string or str parenthesis. I don't even know how you convert things to strings.
I think this is the right syntax, but I'll play it safe, and we'll do that.
Okay. I'm gonna trust that this works, and I guess we'll find out later if we can run the code.
No, yeah, this one definitely works. All right, it's gonna be true. That's gonna be my border island. And now I need to find everything it's connected to and tell it it's a border island as well. All right, so we'll create a new thing up here. We'll call it rec for recurse. And I need to pass in the matrix. We're going to be I, J. Oh my gosh. I have to pass in my border islands too. We're about to find out if things are passed by value or reference in Python. I think I'm going to be fine though.
In Python, you are passing by you are passing the actual entity. Like,
okay. I thought I was going to be okay, but you never know these days.
You're not making copies of border islands, at least not right now.
I wanted to make sure, like, when I put in some values in here that, you know, that actually retains, because we're going to do stuff with border islands later. And then we're going to print out border islands just to make sure I'm remotely on the right path here. And then let's do my recursion. All right, so basically...
And by the way, super quick pause, Ben. I'm just restarting my camera if you want to do the same.
Okay.
Okay, I'm back to being good.
All right, I'm back to being good as well. All right,
Carry on with the interview.
Okay, yeah. Now I just basically need to look up, left, right, down, and if any of those are ones, I stick it inside a border island. So, I guess here's how I know we're done. If, you know what, I'm not gonna do it like that. I'm trying to decide how I want to do error detection. All right, this is going to be my... I hate when I do this. All right, so basically I need to do this, right? Ooh, we're going to do it like this, actually. So 0, 1. These are all my steps. So I'm going to do 4 steps. That, -1. Have you seen this before, by the way?
No, I'm not sure what you're doing.
All right, so these are all the different, I guess you'd say, like, I'm going up, left, right, and then down.
So here, just in the interest of time, Ben, why don't we do, because here you're basically grabbing all the neighbors, right?
Right.
Why don't you just like write a, I don't know, get neighbors function, but you don't have to write it immediately, because I know this is like the annoying, tedious part of the thing. Which
I'm basically there, Clement. I'm going to for loop this, and we're going to be like 4 step and steps, and we're going to like, you know, neighbor here is going to be matrix.
Whoa, I've never seen this.
Yeah, so yeah, you need to, and I'm going to get real crazy here. I don't know if I can destructure this. Actually, should I make this tuple?
I think you can destruct. You can destruct.
Can I destructure arrays too?
I don't know. I don't know. Maybe do them tuples if you want. I think you can.
Wait. Okay. I think I just broke. Okay, I just broke your editor. I'm going to just refresh real quick.
Okay, I'm going to refresh as well.
All right, I'm back. We'll -1 that. All right, we're good. Actually, screw it. We'll do it nice and big. All right, yeah. So we're basically here. So here we're gonna say ix jx for what's being changed in steps, and this is gonna be new I is ix plus. Oh, that's so kind of you. Wait, no, I have to destructure it like this then, right?
Yeah,
Or am I tripping?
I think so.
Okay.
I think even before you had to do that. But just keep
To
writing what
unpack.
you're doing.
Okay.
Yeah.
ix plus I new j. It's like that, and then I have to do it up here. Should I do an is out of bounds function? Nah, we'll just write it ourselves. We're plowing through. If n is equal to, if I is less than 0, or nj less than 0, or ni is greater than the length of the matrix. Yeah. No, actually -1.
Yep.
I may be having off by 1, or
I think
nj is greater than matrix. I'm gonna like do the assumption that there's at least one row in this. I think that's a safe assumption.
Sure, we'll let that slide
1.
for now. Yeah.
We'll let this slide. Okay. Well, I can add like a little if statement at the top if we need to. Wow, this is a beefy if statement. Look at all the stuff you're making me do. Okay, so that's...
Well, that's why you do a helper function like you suggested earlier.
True. But I'm just in the mode, Okay, so we're going to continue if those are all bad.
Okay.
And now we get our neighbor, which is equal to new I, new j. And then if neighbor is equal to a 1, then we're going to stick it in border islands. And we're going to do our dot format new I, new j. And then we recurse again. Yo, this is a nasty problem. New I, new j, matrix, border islands. Okay. Oh, I was literally about to save the HTML page there. Okay, so that's rec. I'm trying to think if we need to return anything from rec. I don't think we do. I think we're actually just good here.
Okay.
We'll pull that down. All right, I want to just run this and actually see what border islands prints. I don't think we have an infinite loop because I have if statements in here. This becomes part of the island. Yeah, okay. I'm going to run the code.
Okay.
I failed the one, and it doesn't like key error 14. You're right. I didn't put true. You see what I did wrong? I didn't put true on line 21. Yep. Yeah. Where are you? There you are.
Oh, right, because you're storing in a dictionary.
Yeah.
Maximum depth exceeded.
Are you kidding me? I definitely thought I was going to be... Oh, you know what? Oh, that's so disgusting. We have a cycle. That's what we have, right?
Yep. Because you are revisiting the same neighbors, Ben.
All right, so I should just see if it's already in the border island. So if nay and if new I... Okay. Wait, so border... Oh, right. So this is... I should build my key. So if key in border islands, then I recurse.
Right, so you're basically using the border islands as the same, like both as a sort of the already visited data structure and as your border islands.
Exactly. All right, I think we're good. I looked at it and there's stuff in it. It kind of looks right. So every time I come across the one and it's not in border islands, I'm just going to kill it. So if value is equal to 1 and not in border islands, not. So we have to build our key dot format ij.
Yeah.
That means matrix ij, and I'm just making it a 0, right? And wait,
Yep.
why am I returning an empty thingy? Am I not returning matrix, or is this like an in place?
Yes, you should. Yeah, you should do it in place. And before you run your code, because I think you finished your for loop here. Before
Yep.
you run your code, why don't you just like let's re-walk through it once to just see like, are you confident that if you run it here, it will work?
Right. Okay, so this is like top level what we're doing here. So one, I'm keeping track of everything that is a border. That's what I'm storing, my little border islands. And then we're looping through the entire matrix until we come across a very important value, which is 1, and that it is a border, because those are the only things that we care about. And 1, if we know it's a border, we're adding it to our border islands. But then we, like, once we have made this a border, we then have to check all the ones that are borders next to this. And so that's why we're, doing recursion. And then we recurse. This is my little algo to check all the different neighbors. Instead of doing 4 if statements, you can do this and you do a for loop. It's my preferred method. I really should have stuck this. This, by the way, could just be wrong. We'll see in a second. But we're just making sure that, like, if we're on the edge, we don't go over. Or sorry, if we're on a border, we don't want to step over the matrix and get a problem.
Yep.
We're just checking if the neighbor is a 1, and if it is, then we know it's next to a border. We're sticking in our border islands, and then we recur again if we don't have that key already. Is that right though? Yeah, no, I think that's good. I'm pretty happy with that. And then after I've stuck everything in border islands, I know all the borders, and so I'm just killing the ones that are not in borders
By reiterating through the entire matrix.
Exactly. And then this is literally just how I'm. This looks a little weird, but this is just how I'm getting the key of border islands.
Okay, and perhaps if you want, Ben, again, before we run the code, because in a real interview, you might not be able to run the code if we were like in a Google Doc. Why don't we try to, because I do think that your algorithm seems sound. Why don't we try to clean this up a little bit? Because you said there are a couple places where you could maybe just like clean it up.
Okay.
And it might
Clean
make
coding.
it easier to debug after.
He's getting a little bit worried. He's not confident in my code. All right, so we'll do we'll add ones for this beefy thing here, which is just like is safe, is outside matrix is basically what I'm asking it. And you could say new I, new J, matrix are the values that I'm passing into that.
Oh, Ben, you're killing me with the inconsistency with your is border parameters that are basically the same as this.
Well, you know why I'm doing that, right? So I don't have to rename it because I have new I here and new I there. Can I do?
I see.
I don't know my highlight. Okay, I actually kind of do it. I think I can do like percent. All right, I don't know if your percent Vim thing works. All right, just for you, okay? It won't take that long.
Ooh,
there you go.
you're overwriting words in a single, like, you're doing some sort of Vim magic here.
Yeah, that's the beauty of Vim right there. So I think this is now is outside matrix. We're gonna return true.
Okay.
Return false. And then is nice, that's auto completion. New I, new J, and then we're gonna pass in our matrix. So if it's outside the matrix, we're gonna continue. That looks good. I really hope I don't refactor and just ruin my code even more. And then we'll add one other thing. This is gonna be border island key. So this is for generating the key for the dictionary. Okay. And I'm gonna just be passing in IJ, and all it's gonna do is it's gonna return dot format IJ.
Okay.
And then we can now get rid of this bit if we wanted to.
Okay, and you can probably use it also down there.
Yep, and basically every... Actually, I probably should have done a search and replace. Oops. There we go. I saved the file again. And yeah, okay, I think that cleans it up quite a bit. I mean, we don't need this. None of these comments were remotely useful. I can kill those.
Okay.
Yeah, I'm pretty happy with this. I'm just running it. I just ran it.
Okay. Looks like there's an issue with your code.
Are you kidding me?
Invalid
I told you.
syntax.
This is
You
a problem with refactoring. Yeah.
You forgot a colon. No, that's fine. Here,
What line was it?
On line 25.
Okay. And
Just a colon after
there
the
it is. Yep.
Okay, so it ran.
It read. Oh, I got some right. Okay.
Yep. So you were getting 11 out of 15. So
this is actually the worst possible situation.
It is actually.
You'd actually rather get them all wrong. All right.
So one thing that you can do is if you look, let's click like for instance test case number 1. Click view outputs side by side, and you might be able to see the diff of where they are different.
Oh, what the heck? This just like took over my full screen. Okay, I see. Oh, this is such a weird view. All right, so the left is. Oh, I got rid of that one. Interesting. All right. I've had enough of this view. I assume I just hit escape.
You can just close the tab. It's a new tab.
Oh, okay.
Yeah, so there must be some small bug in your code. Why don't we just go back through it like line by line?
I bet no. I think I know it. It's probably something. I'm wondering if it has to do with this one.
What line?
On line 8. I wonder if I janked this one up. All right, so length of I matrix. If it's greater than that, then it's a problem. Okay, this is just for kicks, okay? Okay, so let me just see if there's a pattern to the things that I got wrong. So the first one I got wrong is it was missing on the left side. And actually it was missing down to our code's out.
In the first one in your code's output, you removed the few ones that were connected to a border for whatever reason.
Right, which means and notably they're in the inside of the border. Like they're not on the outer level, which means there's something wrong with my recursion. That's why I like immediately went to my recursion thing.
It's like the left and bottom. Now if we look at like test case number 4, I'm gonna go to the diff because it helps me. So our code's output, you removed you removed an island again that was connected in the middle.
Yeah, I did basically just a straight rookie mistake here. So you see how I literally I'm only doing recursion once. I see what my problem is. It's on line 29 and 31.
Okay.
You see how I literally stick the key in border islands, and then I ask if the key is in border islands and not. So this is always false. I'm never doing recursion. Yeah, so that was just a pleb move. Really what I want to ask it is what do I want to ask it? I mean I should really do I think I should do it up here in the neighbors. If neighbors is equal to 1 and we're gonna move key up here and not key in border islands. So I think I just need to move up my thing. I think I always recurse here. All right, I'm feeling good. Yeah, I just jammed it.
Yes, because you were checking the visited in the wrong place. You have to check the visited immediately when you check that it's a 1, but not after you've already set it as visited. Otherwise, you will never recurse down that path, right?
Yep. So I basically my case for not doing recursion, I need to check in a different place up here, higher up.
Yep. Okay. Well, listen, Ben. Are there we still have like about 8 minutes. Let's just do a couple more things. Like, are there any places where you think that you could again clean up the code? Like, if you were looking at it, just to see.
I mean, I could probably think of a better name for border island key, though. I mean, it's pretty deep. Like, it's decent. I'm happy with it. Border islands, I probably could give a better name. As far as like, I don't know, I'm pretty happy with my work here.
Yeah, this looks decent. Yeah, this wasn't like a trick question or anything.
No, yeah, I mean, I'm just going over the code now,
One of
And
the things that for me like is striking, but it's a small thing, is just like is border and is outside matrix have the exact same, or in my opinion, they should have the same function signature because like you're doing very similar actions, whereas here you
oh yeah,
decided
yeah. I
to
just
pass them.
decided to put matrix in there. Yeah, yeah. I
One
see
or
what you
the
mean.
other to me works better. I would
Right.
probably prefer matrix. Yeah,
I could have just done this here, for
yeah.
example. Yeah. So let's just show them real quick. So I could have done this, and then well, this is gonna be gross now. Let me undo. Row length, and I basically do what I did to compute the row length inside of it, just
Yeah, which
encapsulate
would
it a little bit.
it would just be len of matrix -1. Yeah. No, you still have to do
Yeah, yeah.
I equals.
My brain's fried after doing way too much thinking, and we did matrix 0 here. I think that's all I needed. And
-1 again.
oh, right. Good catch. And we'll get rid of this.
Len of matrix. Wait, len of matrix -1. Yeah.
Okay. Actually, you know what? I got like too caught on my little graph theory kick because it looked like such a graph problem. I should have just treated it like a graph matrix and pretended I knew how those worked.
Yeah, I mean it's funny because like if you just take a step back here, just for I guess the feedback that I'll give is like your very first intuition was correct. Like this is a graph problem to some extent, and you are traversing that graph with depth first search. That's like the most intuitive way to solve the problem. But you don't like just because it's a graph problem doesn't mean that it needs to be like complicated. You already have the graph, and traversing a depth first search is just going through the neighbors up, left, right, and down. I guess one question that I could ask you is like, what is the time and space complexity of your algorithm, and do you feel like there's a way to optimize it, or are you comfortable with the solution?
There may be a way to optimize it because we're literally doing recursion on every one, but I think it's pretty good. So I mean, one, we're doing O of n squared because we're going over the entire matrix. And then inside the matrix,
and m because it's not necessarily a square matrix,
fair enough.
but sure.
Yeah. There you go.
Why another m?
Sorry. I just meant to put one.
Yeah.
And then inside the actual, so like we're calling this rec function inside of double for loops. So we then have to compute whatever the space complexity of rec is, which I'm pretty sure it's some logarithmic thing. We're doing a for loop of steps. So actually that's constant. I'm not sure how. I mean, okay, the worst case scenario of recurse is we do the entire matrix again. Like we iterate through the entire matrix.
Exactly. So basically, and since you have your visited checks, right? You check if it's already a border island, and you don't revisit it. You're actually never going to revisit islands multiple times, right?
Right. Oh, I guess. So okay. So I loop through this. Like, let's pretend these are all ones. All. Right, it's not really easy. I was gonna do a search and replace, but that's one. So this is what I'm thinking about: is if the matrix was entirely a sheet of ones, right?
Yep.
So I would mark the outer thingies as. No, I'm pretty sure we would still. I'm pretty sure this is like we're multiplying this times an m or an n at least, because we're gonna be recurring, and when we do recursion, we're gonna touch every one.
Yes, but only once. The only thing is like maybe to make this more clear, what you could do here. But this is purely to make this overwhelmingly clear. Here you could say like on line 41, you could say if. How do you check if it's in border? If I guess. Let me do this. If border island key ij, if border is in border islands, then continue. And you will only, like you would start at the top left corner, right? You would mark this as a border island. You would recurse through the entire matrix, because let's say they're all border islands. And then for every single other one, you just skip them. Like you would traverse through them once, but you would skip
Right.
them immediately on line 41.
So it's like a plus n, and then we just kill that
And
anyway,
then you kill
'cause
it.
of
And then
Big O.
on
Okay.
the second loop here, 46 to 49, same thing. You're just reiterating once through the entire matrix, but that's like fine. So it's like 2 times NM.
Which is just, it simplifies to the same thing.
What can be tricky about this type of algorithm to come up with that space complexity or time complexity is like you said, in the recursion here, depending on where you put your check to not like re-recurse, you might feel like
Right.
you're doing way more work, but even there, at most, you're just revisiting 4 neighbors, but then stopping, right? So it's like at most,
Right.
for every key, you're doing another 4 extra operations,
It's always going to be
that's-
constant-ish.
but that's constant with the input, exactly.
Yeah. That's a good
All
point.
right, well, listen, Ben, I think we made it in time. Good job. I think that yeah, good job. I mean, at the beginning there was a little bit of bit of confusion, and I gave you a few hints to lead you in the right direction.
Thank you for holding my hand.
But I still think that I think you had the right intuition, and the code. This is like a relatively difficult thing to code out in full. And it's certainly more difficult if you can't run the input output. But you had very few sort of like genuine algorithmic mistakes, except that one recursion. That one recursion thing would have been
this would have been hard to catch without running it.
Yeah, the thing like the missing colon on the if, that doesn't matter.
Well, yeah, that's
But and everything else was sound. This was the only thing, and that would have been tricky to catch. It would have been interesting. If we been in a Google Doc, I would have had you walk through line by line, and maybe we would have caught it there. But yeah, good job.
Wait. So did you catch this, by the way?
No, when we were doing it, no, I didn't catch it immediately. But maybe I would have caught it if we had kind of walked through it.
So
more line by
theoretically,
line.
if we're both in Google Docs, you could have just thought I did it right too. So I kind of Houdini'd that.
It can happen, but again, we would probably have spent a little bit more time looking through it. But yeah, it to some extent it can happen. That's why it is very important though to communicate. And I would have had you walk us through a couple of examples, walk you through the sample input. And to be honest, the sample input would have failed, right? That was one of the 4 test cases that failed.
Right.
So had we walked through that line by line, or you had run the algorithm on that, it would have failed. So
I mean, this one's kind of disgusting to do manually because it's just so fat.
It is, yeah, it is. But you can just try going at the islands,
the
right?
good ones.
You would have probably seen that from this one, you'd have gone there, and then you would have seen oh wait, I'm not based on my code. If I hit this will always be true, and I'll never visit it.
Yeah.
But cool. All right. That concludes the medium difficulty mock Google coding interview, Ben. Overall here, I think if we were in a real coding interview, I'd probably give you somewhere between I don't know, a leaning higher or a higher, something like that. There weren't any, huge mistakes.
Wait, so even though I was totally in the wrong direction at the beginning, this was enough. I recovered enough to get leaning higher.
I would say leaning higher because and I would have to go through the rubric. I could go through the rubric right now of mock interviews. We have a rubric, but let's put it this way. Algorithmically, I did give you a decent amount of hints, and you were going down a few paths that seemed
I was
really,
expecting to get borderline pass at most.
So again, I think leaning higher is probably the fair. I tend to be a little bit nicer, so I don't want to I don't want to be strong no higher. But this is not a strong no higher. This is a leaning, in my opinion. So either a leaning higher or a leaning no higher. Again, the reason is algorithmically, I think you were in that middle thing of if there are 4 scores, you were probably in a somewhere between a 2 and a 3 because I did give you quite a few hints and.
I was going to make an adjacency list, yeah.
And the adjacency list, I don't think would have brought you anywhere, at least not in the way you were doing it. Coding-wise, I think you were able to transcribe your algorithm into code very well, and you were able to clean it up where when it made sense. So coding-wise, I would give you between a 3 and a 4, 4 being the maximum. Communication-wise, I'd say you were pretty good at communicating. Again, at the beginning, maybe not. I had to push you a little bit to kind of walk me through the adjacency list and all that. And like the edges and border, you got to be careful with that, right? If you're talking about edges in a graph, like, that can be confusing. But so communication probably between like right around a 3. And problem solving, I think your problem solving was pretty good. You did like think about how you could go through a graph, how you could, depth first search. You added a little bit of color by saying that some of your algorithms were trash, which I don't know if that would be super appreciated in a real interview, but
You like my steps thing though, right? That was pretty nice.
Your steps thing definitely wowed me, and so that pushed me over. You see, the steps thing is what pushed me from a leaning no higher to a leaning higher.
Okay, excellent. I'm gonna keep that in for my next Google Docs.
But seriously, again, in all honesty, I think that you did a pretty good job. And to anybody who's watching, especially for someone who, as far as I know, you don't really do you don't practice coding interviews these days. No,
that's why I was like, I don't remember adjacency matrix things at all. That's why I was like, let's put this in a list.
But yeah, so good job, and maybe we will do a third interview that will be of hard difficulty, so to speak, another time.
Cool.
All right. Hope you all enjoyed that. We are about to do a React interview on Ben's channel. He's going to be interviewing me for an intermediate level or medium difficulty level React interview. So wish me luck. The link will be in the description and in the comments below. And otherwise, don't forget to smash the like button. Subscribe to the channel if you haven't already. Follow me on LinkedIn and Twitter if you enjoy short form written content. Instagram if you like pictures. And I will see you in the next video.